So what we have here is an example dashboard we put together, really focusing on monitoring your engineering hazards. So front and center here, what we're seeing is our real-time torque and drag piece. Now, many of you in the industry are already familiar with broomstick plots. I won't spend too much time getting on this. We have a lot of other sessions here, how things are calculated. But for our sales team or even some of the technical support folks, what's happening here is Corva's running all of the inputs through a soft string model. It's generating these friction factors automatically based on surveys, wellbore trajectory, target changes, mud density, mud properties, all those inputs that you have to manage. So if you had to do these in some more like legacy toolkits, it's a bit of a manual process. This really automates a lot of that. The benefit of this also is that it captures pickup, slack off, rotating weights automatically, and more importantly, systematically every time, and then overlays them on top of your friction factors so you can see if you're starting to deviate from those trends. We also incorporate tripping speeds, so if you wanted to compare, basically, okay, if we start upping our running speeds or slowing them, what is the impact on our friction factors? Are we buckling the pipe, etc. So we have many workflows with many customers using our real-time torque and drag, especially for the final in the unconventional space at the final well TD. So many of them have their own practices for pulling 5 stands, then looking at the friction factors, and then evaluating from there if they need to go back to bottom, do a cleanup cycle. So a lot of workflows on that, but basically you can track your entire pull out of hole. The models are calibrated by Corva's ops team automatically within the first 200, 500 feet of drilling, and then the model and the physics engine just run in the background, plotting everything together. So basically, once you see you have a clean pull out of hole, a lot of operators, what they'll do is then use that information to help calibrate or look into their production casing running. So you can drill the fastest hole in the world, but if you can't get production casing to bottom, it's not that great of a sell for a customer. So the big benefit of Corva is that we're tracking all this information, and we build out the detailed casing specifications. If they're floating casing or running anything advanced, it's going to track this in real time as you go. So this is how your field teams are able to then, focus on running their equipment very safely, and then looking up at a glance to see how their actual points are trending versus their friction factors. So say there's a case where you're running some very specialty equipment. Maybe you're doing a pull down sub, or you've got dual airlock, or maybe you're even running a downhole swivel sub or something very extreme. If you want to import your own model, we built that mechanism in here, so we can upload that and tie it to the individual BHA or casing runs, and then the user can then toggle between Corva's model versus yours. The point capture here will exist, so we'll capture the points on top of your model or on ours, depending on what you wish. So we have many case studies really focusing on how this has helped benefit our customers globally. So it's a very powerful and popular tool. Another one that I like quite a bit really kind of ties back into the ROP performance piece. So say you've done all your weight checks, you're using all the correct parameters, but you're still not getting the anticipated ROP that you expect. What we have here is a live buckling load analysis that's modeling all of your axial loads or from your drill pipe, and then correlating them against your sinusoidal and helical buckling limits. So what we've seen with actually several customers, very common to see pipe buckling above kickoff point. We have a few case studies where we actually went to the customer and showed them this data, and they were able to adjust their BHA design, adding more heavyweight accordingly to keep that from happening moving forward. So I've had a lot of good cases from that. Other tools really focusing on wellbore tortuosity. Basically, this is calculated from your dogleg severity. That's calculated survey to survey. We can also overlay offsets here if we wish. If you want to track your planned dog legs versus your actual. We also have 3 different tortuosity indices here, so you can track those well over well. So customers have liked that, especially in conjunction with torque and drag. I mean, there's obviously a relationship here with a more tortuous wellbore versus higher friction. The other tool here that we have published an SPE paper on, and this is also an operator-led development. Very simple here with what it's doing, but the problem that it's solving is that customers were wringing out many bits from off-bottom whirl, as well as some other customers were actually chunking motors prematurely. So what this tool is doing to help solve those problems is checking stand over stand, did the driller zero their differential pressure correctly within plus or minus a certain tolerance? Same thing with zeroing weight on bit, and did they wash back to bottom with a reduced RPM? And tracking that every single connection, every single back to bottom, as well as segregating it by day and night crew, you can see very clearly, are you following those best practices? So after implementing this with many customers, we found basically, in the Eagle Ford, one operator went from 3 dedicated runs for curve and lateral. Now they're doing 2, and one of them is a planned trip at curve land out to dial back the motor. So basically they're effectively getting to plan TD in one run on average every time now after implementing this. Obviously there's more into that, but their root problem is that they weren't zeroing differential pressure consistently or correctly. The other tools here I want to focus on are related to well control monitoring, flowback fingerprinting, very common, especially offshore. So basically, what is the behavior of the pits or the flowback to the active pits here in green every time you kick the pumps off. I also have here flow in. So when you kick the pumps off, you can kind of see that for reference. We can also pull in flow out. If you want to do a flow check on the trip tank, you can see that. So very nice here. I also like that you can do look backs very cleanly. And this also ties into Corva's alerts engine. So we have, I can't remember if it's like 10 or 12 different alerts. They kind of tie in. So if there's a deviation from flowback, it'll trigger an alert state and help people then take action. Other tools here, automated trip sheet. So any of the deep water mud loggers or assistant drillers that have spent time doing this, we know that this will take a good bit of your time, for every single run in or out of the hole. So what's happening here is Corva is looking at basically each stand of start depth, end depth, trip footage, looking at the start volume of our trip tanks as well as our active pits, and automatically reconciling closed-ended or open-ended displacement. So it does that automatically, and again we have alerts that trigger in there. The last tool here really focused on surgeon swab. So we found with a lot of our customers that most of them, especially offshore, are doing surgeon swab modeling basically pre-run or in the design phase. So they'll put in their hard limits, and basically that's the theoretical max that the team will then use going forward. There aren't many customers that have been doing real-time monitoring of this. So what Corva's doing, similar to our torque and drag, is we are actually calculating using our rig states here to see what is our effective bottom hole pressure every single, double, or stand or quad that's running hole. We also have pulled in the pore pressure and frac rate windows here, so you can track yourself relative to your drilling window here. Also overlay your individual formations. The beauty of this is that it also incorporates modeled times, but modeled ECDs as well. So if you were to increase your running speed from 50 feet a minute to 100 to 200 to 300, what is the implication of your bottom hole pressure? It also pulls in your mud pump state, your live mud weights. If you have an MPD system, it'll pull in your MPD back pressure, as well as if you're running through a Coriolis, we can live consume that mud density data as well. So that way, these calculations are very, very tight. And again, really helps to get to section TD to trip in, trip out with the optimal parameters. So this, in conjunction with Tripping Speeds app and with other workflows in Corva, really finds that optimal sweet spot for performance.